Chapter 2.8 is about the curved arrows. This is our curved arrow, this is its head, and this is its tail. The curved arrow allows us to show mechanisms on how electrons or pi bonds will move. And so, the first rule with curved arrows is to always have tail at electrons, lone pair, or pi bonds. The second rule is to avoid breaking sigma bonds or single bonds. And the third rule is to not exceed octet on carbon, nitrogen, and oxygen. In the example below, the curved arrow would start off over here at these two lone pairs with a tail, and it would have the head pointing towards the single bond. However, that would exceed the octet for this carbon, which means that another arrow pushing mechanism would occur with the tail at that pi bond, dropping off 2 electrons over here at that carbon. And by the way, this is our resonance structure arrow. It shows that there is resonance, and that means that these 2 molecules would exist at the same time or shift in between each other. 2.10 is about being able to recognize structures that can help you form resonant structures, or recognizing patterns that could help you form resonant structures. The main pattern that would allow you to be able to identify a resonant structure is something allylic, which means it is one away from something vinylic. In the example, allylic lone pair, these electrons are allylic to this double bond, and so the arrow pushing mechanism would be like this and like this, with the electrons moving to form a double bond and the pi bond forming, just dropping off over here for 2 electrons. In this example, the electrons over here at this nitrogen goes to this bond. However, that would exceed the octet over here, so this pi bond will go over here to this oxygen, which means this will be a positive charge and this will be a negative charge. One thing to remember is that when you're doing resonance structures, the overall charge is always the same. So this positive cancels out with the negative over there. Now, in an allylic carbocation, you recognize that over here is a carbocation. It is positive and it has room for electrons, which means that an arrow pushing mechanism could occur from this pi bond over here to this single bond, which leads to this resonance structure, and once again, a positive carbocation. And this structure below, the resonance structure will look something like this, this, and this. Lone pair adjacent to a carbocation, or a positively charged ion, would just be lone pair electrons that are literally adjacent and could move over. Another pattern is pi bond between 2 atoms of different electronegativities, which is basically just reversing the lone pairs adjacent to the ion. And the final pattern is conjugated pi bond in a ring. Basically, the arrow pushing mechanism would look like this, where it would shift over and around, rotating endlessly, and this only occurs in aromatic. That is all.